Hello, Mr. Wachtel's current AP Calculus AB class. My name is Jared Taylor, and welcome to my introduction to volume using the disk method. So, the disk method is a method used to find the volume of solid that is created when the graph of a function from point A to B is rotated around a line. So we have here our equation for the disk method. Before we get into that, I'm going to write down a little bit of back history for this equation. So the volume equation for this disk method stems from the volume of a cylinder, which is going to be pi r squared times the height. So there are correlations between this, obviously, since this one stems from this one, but the pi is just kind of there to say, like, hey, this equation is being rotated in a circle. So that one's just kind of a given. And then r squared and h are the ones that kind of don't make a whole lot of sense in regards to the equation. So r squared here refers to the r of x. The reason for this is because when you take a function and you rotate it around the line, the distance from the line to the function is going to always be your radius, because each side is going to be the exact same area. And now the h here refers to the integral from a to b. Now I'm sure you guys have already done the fundamental theorem of calculus, and that's going to be really helpful when you do this equation, because there are times where the AP exam is going to say, hey, do this without a calculator. It's a huge pain, but you'll be okay, because at that point I'm sure you'll understand the disk method. The reason that the h refers to the integral from a to b is because when you take the integral from a to b of the equation, whatever equation is you're using, h is going to refer to the change in x between a to b. And then that's just going to be your height, because if you take the height of the actual function, the height's always changing. That's why the r of x is there. So you have to take the height as if it's kind of sideways. And so I can talk about this really all I want, but it's not really going to matter much to you guys if you don't do some practice. So I'll write down some practice, and yeah. Okay, so this is going to be our first practice problem. As you can see, they can be pretty simple. I took this one off of Khan Academy, so it's a good practice problem. But we're going to go ahead and start. So the question says, let R be the region enclosed by the positive x-axis and the positive y-axis, and the curve y equals the square root of 9 minus x squared. So that, obviously, you can see here is what R is. It's going to be this big area right here. So a solid is generated by rotating R around the x-axis. So that's saying, hey, we're going to go, if this is the x-axis right here, we're going to go around it like that. That'll be your solid. So the way you set this up, start using the disk method, is going to be this way. You're going to write down your equation, real simple, and then you're going to look at this and say, what is going to be my interval from a to b? So for this particular equation, you're going to go from the integral from 0 to 3. The reason for this is because since the region is only being enclosed by the positive y-axis here, you can't take anything in the negative y-axis, and that's where and then right here at 3, x equals 3 is where the function crosses from the positive y-axis to the negative y-axis. So you can't take that when you're revolving your function around the x-axis. So you're going to set that up. You're going to say, oh yeah, so the integral is going to be from 0 to 3, and because it's already given you your y of x here, you're going to say, okay, so the r of x is going to be the square root of 9 minus x squared, and then that's what the equation is going to look like for now. So then you start solving, and you're going to take the integral of that. Since the square root of something is squared, it gets rid of both the square root and the squared. So you're just going to have the integral from 0 to 3 of 9 minus x squared dx. integrate it, and you're going to get 9x minus x cubed over 3, the definite integral of that. So then you use the fundamental theory of calculus, and you're going to get pi times 27 minus 9 minus 0. And so the volume will end up equaling 18 pi units cubed. Never forget your units. If anything at all gives you points, especially on the free response on the AP exam, it's units. I don't know if Mr. Wachtel's shown you the practice problems yet, but there are times where literally just putting units down for all of your answers, where it's necessary, of course, will give you a point, at least a point. So always remember your units. But that is how you work out this equation right here. Set it up first, start plugging in all the variables and the equations, evaluate it, and boom, you have your answer. So that would be 18 pi units cubed. And of course, if you got a calculator, you can go ahead and it's allowed, you can go ahead and plug in this integral right here and it'll give you the answer right away. But it's always best to know how to do it without a calculator. So we're gonna do 2 or 3 more problems. The next one I'm gonna have you do on your own. All right, so we have here our second practice problem, and I'm gonna let you do it on your own. But first, I'm gonna point out some little tricky pieces here. So you must always remember to pay attention to your boundaries. Okay, so for this particular equation, for this particular question, it's asking you to bound the region by x equals 1 and x equals 2 and the x-axis. And so, as you can see here, you're not going to take the area of this little piece right here, and your integral is going to be from 1 to 2, because that's how far it goes. And so it's going to be generated by rotating r around the x-axis, and go ahead and try it by yourself. Okay, so here's my work. Obviously, as you can see, you take a square of a square, so it's going to become x to the 4th. I skipped a few steps here because I didn't feel like writing it out. It's going to turn into the integral from 1 to 2 of x to the 4th. You take the definite integral of that, and it's going to be x to the 5th over 5. And then because you're using this disk method, it's going to be times pi. You're going to evaluate that, and it's going to come out to be 31 pi over 5. Okay, so this is number 3. It's pretty much the exact same thing as the other two, only this time there's a twist. So notice that you have 4 boundaries here. You got the x-axis, the y-axis, y equals 2, and the curve, the square root of 9 minus x squared. Also notice that you're rotating around the y-axis this time. So this is one of the trickier ones that the AP test will pull on you. Always make sure that you are reading the question entirely. I had a lot of issues with that in the early bit of the year on my year that I learned calculus. So there were a few problems I would get wrong about this because of that. Don't make my mistake. Always make sure you're reading the question. So on this particular equation, since you're not rotating r around the x-axis, you're rotating around y. You have to switch the equation so that it's not y equals, it's got to be x equals. So to do this, you're just going to do some algebra, move it over, and so I'm going to erase that real quick and start. So you got y equals the square root of 9 minus x squared. You square both sides. Y squared equals 9 minus x squared. You're going to subtract 9 over, so it becomes y squared minus 9 equals negative x squared. and then you're going to subtract both sides by a negative because you can't have a negative variable that you're solving for. It's going to be x squared equals 9 minus y squared because it flips the signs. And then you're going to square root that, so the final equation you're going to end up with that you will put into your r of x is going to be the square root of 9 minus y squared. And so at that point, you are just going to end up plugging it into your disk method equation and pretty much just solve it that way. Only this time, since you're using the y-axis, you take the bound of the y-axis, so it's going to be from y equals 0 to y equals 2. So make sure you're paying attention to that as well. And then you just solve it, and it'll give you pretty much the exact same answer you would for as if this was being revolved around the x-axis with the same boundaries, where this is like x equals 2 and stuff. Okay, so here's my work for this equation. I mean, it's pretty much the same thing as it would be if you're rotating on the x-axis. Just make sure that when you're showing your work, you put in dy, since you're taking the integral with respect to y, and then make sure your equation is correct with all the y's and everything. And then, again, don't forget your units. That's a very big one. There's one more we're going to do, where it's going to be rotation around a different line than an axis. So we'll get to that now. Okay, so now we're essentially back to our first practice problem, only this time there's a +4 on it, and the solid is going to be rotated around the line y equals 4. Now this is important because this is probably going to be one of the harder questions you see on the AP exam. Most of the time the equations won't be as simple as this one, and you're going to need to rotate it around a few different lines. This can be done with the y-axis as well, but it's not really a big deal to go over it because it's basically the same thing as what we did for practice problem 3, just applied to this problem. Alright, so in order to do this problem, you're going to need to take the area of R, rotate around this line right here, x equals 4. And now this is important because, you know, it's different from the x-axis. So what you're going to do to solve this one is, because the equation here is up 4, you're going to need to subtract that from the equation itself. So it's going to look a little bit like this. From still 0 to 3, since you're just taking from 0 to 3, and anything below this is out, and the equation is still going to be your original equation, only the only difference is that because your equation is above your y equals 4 line, you're going to subtract 4 from your overall equation. And now, so that basically it just means it's putting it down back to the x-axis as if it's being rotated on the x-axis. And so you would just solve this equation. It would turn into the exact same thing you did for the first practice problem, and go ahead and solve that. And so, yeah, long story short, the only thing that putting it at a different rotation around a line does is it basically just makes it harder. That's all. It's the exact same equation as it is usually. It's just a little bit more difficult to figure out. This method is important for the AP test because they will ask you about something like this, because it is a hard concept that's not really all that easily grasped sometimes. So it's something that they really like to test on, and it's a very, very good question to have for a free response question. So just be careful, make sure you're remembering your units, remember to read the equation all the way, and just have fun with it. It's not exactly as hard as you'd think it would be.